and then we'll start the session.
And yeah, can we start this session?
Yeah, just 1 minute. Ah, now we can start.
Yeah. 78 participants. It's wonderful. Okay. So, hey guys, this is Praveen, also known as SB. I am a volunteer here at Chennai React. We are a community of 4K members and we have conducted over 4 offline events and welcome you all to our very first online event. So, what is Chennai React.js? We are a community of tech enthusiasts like you and me, and we organize events around React.js. So, we like to thank our community partners, Peck Hacks. So this is a 36-hour hackathon, and the registration ends tomorrow. So do register for it, and it has wonderful prize pools. The first prize is around 1 lakh, and next we have Global Freelancers Festival by Makers Tribe. This is a celebration of the freelancing community. It has over 150 stalls, 100 plus guests, and the event happens on November 30th. And finally, TechXConf. This is the Asia's largest AI and cloud conference of 2024. It is a two-day event. We have 70 plus speakers, and it happens on 15th and 16th of November. Cherry on the cake, the Chennai React community have actually partnered with TechXConf to give its community members a special discount of 35 percent offer on the tickets. So you can use this coupon TXCHEREACT24 to avail this offer. So yeah. So before we actually start the event, I would like to tell a few decorums. So the chat is here. If you have any questions, you can ask in the chat, and either Tapas or the Chennai React volunteers will actually answer it. So be respectful in the chat, and also towards the end of the event, you'll have an opportunity to ask direct questions to Tapas. You'll have an opportunity to unmute yourself and ask. And also, towards the end of the event, please do turn on your videos so that we can take a screenshot and post it on LinkedIn. So, so today's event is on React compilers featuring Tapas Adhikary. So he has over 20 plus years of experience. He's the founder of ReactPlay.io, and which is an open source platform for developers. And he's also the founder of RioWise. He also has a YouTube channel called Tapascript by Tapas Adhikary, and he's also a technical writer at Free Code Camp and Hashnam. So these are things that you can find in the internet. But let me tell you something that is not there in the internet. I had the opportunity to meet Tapas at React Nexus, and let me tell you something. For a person of this stature, he has 20 years of experience. He was so approachable and so down to earth. So let's actually sit back, relax, and learn from Tapas. Over to Tapas.
Cool. Thanks a lot, Praveen, and thank you, Chennai React, for inviting me on your first ever online session. I'm really thrilled, and I just wish you a lot that you guys grow because it's not very easy to. Probably it's easy to open and start a community, and not very easy to kind of sustain it. Being a community lead, I can completely understand you guys are doing awesome. So all the best to you all. Um, I just hope my voice is coming very clear to all of you. And today we are going to talk about React compiler. So let me go ahead and share my screen. Just need a confirmation from one of you that my screen is visible.
Yep.
Yeah.
All right, great. So, folks, I see close to 80. That's great. Saturday, almost late afternoon. Are not lazy. You are here and want to listen to us talking about React compiler. So this is of late one of the favorite topic. And Praveen mentioned about React Nexus. So when I went to this year React Nexus as an international event, and I got an opportunity to host a fireside chat with some folks from Meta, and there we got a deep down into React compiler, React 19, and that kept me curious about this part of React, which is not yet in production, and people are not actually using it in production, but it has a lot of potential. So one of the fact that actually caught my attention pretty well is React compiler. So today we are going to talk about it, but before that, something without which session cannot go away is like my introduction. It is already done by Praveen very well, so I won't go through it. Just wanted to call out, like, I have been coding for several years now, and also reviewing a lot of code, being part of the open source community, open source project, contributing to open source project. So would like to really encourage all of you to look into open source as a developer, because there is lot in open source for you and vice versa. So please check it out, and that will be really great. I also teach on my YouTube channel. Whose handle is at Tapas Adhikary. You can check out the channel, and if you feel good about it, you can learn from me. You can subscribe to that. All right. So with that, what can we expect today? So I'm going to talk about React's optimization, and I'm actually assuming that most of you have a background of React. If not, you understand like what React is, what it is for. That is required for this particular session. And I'm going to also touch base a bit about React 19. Of course, we're going to talk about compiler. So I'm going to talk about compiler, going to talk about React compiler architecture, then going to see some project code, going to do some code, in the session. Then we'll be doing some more architectural deep dive and some tips and tricks, and we'll end it. Now, I actually took the term architecture twice, so don't be scared saying that it is going to be a very boring, huge, big talk. I'm sure that it is going to be fun. And if you find it fun, fun and useful, put some reactions. I think that will be really good to know like how you feeling. All right, so let's talk about optimizations first. What is optimizations? And this term is very tricky because we developer are very liberal, and something come to us, we always get very hype, jump on it, be it performance tuning, be it taking care of security, be it optimizing something. We are always there, right? We are always pumped up for doing this. So optimization is a way where you make any application, in the context of an application, more optimal to run, so that it is going to reduce cost for you, it is going to be more performant, it is going to be probably more secure some way, and at the end your end user's life will be very, very good. They will find it very good. The UX of the application will be improved a lot. Now, people who have been using React for a while and is there in the market since long, right? You know that we already do some amount of optimizations in React. We have something called key. So when you are having list of elements to render in React, you use something called key, and that is probably your very, very basic way of optimizing a React app, so that when React is performing on the virtual DOM, doing the diff algorithm, doing the reconciliation, it understand like how fast which particular element in the list should be updated, instead of iterating through the entire list. Consider if there are 100 of elements, instead of going through the entire list selectively, where exactly the update happens in the list, and it can smartly optimized way can update that particular element. So that is a very, very basic optimization is there in React. Then we have something called lazy loading. We can do lazy loading of images, so that you don't have to really load all the images, upfront. When you scroll down, you can actually load certain images over there, and then when you scroll down more, then you load the next set of images. So that is another optimization, image optimization that you can do. Components optimization, right? So React is all about components. Now you get the components, and then you try to architect your application. For that, you have to import the component and you have to use the component. Now, while importing the component, there might be certain things which you have imported into your parent component, but you are really not using it actively when user is seeing the rendered application at that point of time. So you want to do the optimization in such a way that when user is seeing a portion of the UI, and if a component makes sense to contribute to that portion of the UI to come up, only then that component will be loaded. So you do something like code splitting. There is a concept of suspense. You do lazy loading. You do dynamic component import. All these factors are part of your optimization. So another optimization technique you already know if you're working on React. Apart from that, you have React.memo higher order function. You have two beautiful hook, use memo and use callback. That basically helps you in memoization. So memoization is a technique. Basically, it's not part of React. It's basically part of programming fundamentals. What is memoization is? It's a way to make your application faster by caching something. So you cache it so that whenever you need it next time, first you check in the cache. If you find it in the cache, serve it from the cache. If you don't find it in the cache, you go to the store, get the fresh copy of it. or your cache data gets stale, it is very old, then you notify some way to your client goes to the actual store and get you the relevant data. That is a technique of memoizations. So this memoization technique was brought into React using react.memo, where you can memoize a particular component. You say that until unless an input to a component, what is the input to a component? Is a props. Until unless a props gets changed, I'm not going to re-render this component. You used to do that using react.memo. Then from the old school higher order component, the new school hooks came in React, and that's where use memo use callback came, which helps to memorize a value or a function, right? So that's what we know. So these are bunch of techniques already exist in React today to optimize your application. But in the beginning, I started by saying that we are developers and we are highly optimistic. We should be highly optimistic always, because that's how we invent and discover a lot of new stuff, right? We create libraries, framework. We are the people who do it. But sometimes we overthink, and as we overthink, we also do over optimization. And whoever Spider-Man fan, that Uncle Ben has said that with great power come great responsibility. So as a developer, we also need to be responsible, like where we need to go for optimization, where to know for go for performance tuning, where we have to really kill the security. We need to draw that line. We need to be that balance space to do the balancing act, right? So we need to be responsible when you're thinking about optimizing. What happened in last few years, especially from the open source background, I'm saying a lot of contribution that comes in, where I have found very unnecessary usage of use memo, use callback, where things could have been handled much straightforward way. But it is not a big fault of the developer who has done it, because the intention was to optimize it. Because there was a scenario, probably the developer failed that the props change, and because of that I want to cache this part of the component, and based on the change of the props I want to optimize this particular component. But probably the developer forgot to ask himself or herself how frequently that props change. What is the use case that makes that props change very frequently? Because every optimization is having certain kind of cost. As you are looking into the cache, whether your data is there in the cache or not, and then you go to the actual store to get it, the your traversal to the cache, in case you have a cache miss, you don't get the things in the cache, actually a little bit of effort, isn't it, that you try to find it in the cache, it is not there, then you go to the data store, then going to the data store directly, right? So when you do the optimization, you also need to think about all other surrounding cases, like when exactly your app needs to be optimized. So as this control was given to us as a developer, we did our best guess. And we were not the creator of React. I mean, most of us are not the creator of React, or most of us not probably the contributor to React. So as the power is given to the consumer, we are doing this optimization completely in our way. So that's when probably React team has thought that why don't we get this optimization power to the library itself? Why don't we create something which will optimize the app at the background, where developer really don't have to take that headache of optimizations much. Developers will focus on building the user interfaces, designing the user interfaces. They will focus on building the logic. They will focus on giving the proper variable name, than thinking about the optimization. So then React came up with something called a React compiler, which can be used as a built-in tool. We'll see that with your React code base, precisely with React 19 code base, and that can optimize. You can configure it to optimize your React application. So does it mean that once you use React compiler, you will stop using react.memo, use callback? My answer would be yes, pretty much. You probably don't have to use it until otherwise you really require it for a very selective use cases. Okay, so let's go ahead and dive into the fact of React 19 and see like how React compiler came into React 19. So React 19 came up with a lot of features. It came up with the concept of server components. Folks who are using Next.js already probably know about server component. With Next.js 15, it is officially React 19 is inside. That is already inside Next 15. So server components is there. Actions, server function or the server actions. The greater way of handling web components that actually got into React 19. Previously, I'm not sure if any of you tried to create an Angular component and tried to use it inside React. Have you ever tried to do that? The way that you can actually manage to do that using web component, and with React component, creating a web component and kind of bringing them together is always been a challenge. It's not so organic. So with React 19, we'll get that organic way of doing that. Lot of good way of managing SEO and the metadata. There are a lot of hooks related to the form that we have got. We've got a great API hook called use for asynchronous call and suspense management. We can pass the ref as a props. That's another feature. And a lot of optimizations again on in terms of asset loading, like your font loading, your image loading, and all these things. And along with that, we also got React compiler. But there is a difference between all these aspects and the React compiler is all the other things are part of React 19 bundle itself. It means you have React 19 and you have a project built on React 19 or you're coding on React 19 project, you can take advantage of all these things being part of React 19 ecosystem itself. But React compiler is a bit different. It is not shipped along with React 19. Rather, it's a standalone, separated out, built-time tool that you can configure with your React 19 if you want. If you don't want, you can still go ahead with the use memo, use callback way, no worries. But if you want this compiler to act on your React 19 code, now you can configure with your application. That's how it is different than any other feature. If anyone here interested in knowing more about React 19 features or getting into more deeper on server actions, server components, I have a video for it. You can scan that QR code if you want, or we'll share that link also later point in time with Praveen or team. They can share. You will get more deep dive on the React 19 as a whole. All right, so let's get into compiler. But before that, let me talk a little bit about compiler in a general. So when you're talking about the React compiler, right? So in our computer science and engineering, I'm sure who are from that background, uh, you got compiler in your syllabus. I was kind of tortured with this compiler when I studied my computer engineering. It was difficult for me to understand what compiler does. And I remember like in one of our project, we had to build a compiler. So it was like more horrible stuff. So let's understand like what is a compiler and what kind of steps a compiler goes through, so that when we come to React compiler, we'll be able to associate it and we'll be able to understand it much better way. So if you are able to see this image, let me just take you through on each of these phases that will explain like what a compiler does at very high level. Okay. So this one is your source code in any language, any programming language. Now compiler has few steps. Each of the steps are responsible for doing something. And at the end of it, what it generates, a byte code or a machine understandable code. Because your computer, your machine doesn't understand const abcd equals to hello. It doesn't understand any programming language syntax that we write. But what it understands is finally understand the machine code or the byte code. That's what it executes. So it means that the code that we are writing, it has to be compiled and we have to get an output that machine understand at the end of the day. So the code has to traverse through a few steps, step by step, and then finally the machine code or the byte code has to be generated. Don't read too much deep into it, just try to understand it very high level, okay? And try to visualize as I'm speaking. So there is a line of code, let's say const count equals to 10. Now this particular line of code, that goes into something called lexical analyzer. What lexical analyzer does is like it tokenize your code. Tokenize means const count equals to 10. It will break this into different kind of token. Const is one token, count is one, equals is one, the value 10 is another token. Okay, this is what's this lexical analyzer job. Now, as the tokens are there, that goes as an input to the syntax analyzer, where syntax analyzer put this token into something called an abstract syntax tree. This is the term AST. I was terrified in my college days, but now I understand. If you know AST, you know what is AST, but at a very high level, it will create a kind of tree structure where each of these token can be meaningfully placed. Okay, so for example, there is a equal, right? So the grammar of the language might say at the equal left side of the equal there can be something, at the right side of the equal can be only a value or an expression or something like that. That may be the grammar of the language. Based on that, the syntax analyzer will create an AST, an abstract syntax tree, and then pass the tree to the semantic analyzer. What semantic analyzer is going to do, its job is to validate whether that tree is correct or not. So if the tree structure is not as per the grammar of the language, when you speak language English, right, it has grammar, right? If we don't speak grammatically correct English, and if we go to a probably British country, they might feel it little bit odd because we are not talking correct English. Similarly, for programming language also there are grammar, there are certain ways of doing things, and if we don't do that, if we don't get adhered to that, what it does, it gives us error. We get the error, right? We get all this error in our browser console and all these places. So here the semantic analyzer is the place where it is going to validate that AST and try to figure out whether we have adhered to that programming language grammar completely, or we have done some mistake somewhere. If we have done some mistake somewhere, from here itself we are going to get the error. It is not going to go any further because there is no point of generating a bytecode which is having error. Now let's say the code looks great, it's got validated. It will go and generate something which is called an intermediate code or IR code. The term is like IR code. In this case, there are multiple types of analysis of the code done, and then some kind of optimizations will be done. And then the main optimization will be done in the code optimization, maybe dead code removal, all these factors will be done on the IR code. And finally, a bytecode would be generated, and that is what would be executed. So this is how, at a very, very high level, as I told, the compiler works. Now, when you're talking about React compiler, of course, some of these steps are inevitable. It will be there, and we have to really make our React code, which is like the component or the hooks, has to pass through these phases some way to create something that finally the React engine will understand. Okay, so what exactly happened in the React compiler case? Let's understand that. I hope this is understood to everyone. In case of React compiler, it is recommended that we use the React compiler always with a React 19 project. We can use the React compiler with React 18 also, with hooks and crooks and some way with polyfill and other stuff. But it is advisable by the React team that we start using it with the React 19 project. And as I told, that React compiler is not part of the React 19 bundle itself, rather you have to configure it with any React 19 project. That's what I'm trying to kind of visualize it with this diagram. It has three major components, React compiler. One is the compiler core logic, which does all the optimizations, analysis, and all these things. There is something like a Babel plugin. You guys know Babel, I'm sure. If you're a web developer, you know, right? Which transform the code basically. And there is a ESLint. So again, if you are a developer, web developer, you know ESLint, which validates, catches error, and report the error and everything, right? So when we use React or React component or the React hook, there are certain rules that we have to adhere to, right? We know, like, we cannot use a hook within the function, in the conditional statement, within the loop. That's a rule of React. Like that, there are multiple rule of React for creating components, creating hook, maintaining hook. All those validation aspects are put into ESLint plugin. Okay, so this is what the plugin's job. It just catch and report any kind of violation that is there in the rules of React. Okay, rules of React is not new and not related to React 19. It is there since the first day of React. Only thing is, like, it is getting enhanced as and when we are getting new React features, getting introduced to. So Babel plugin, what it does, its job is to transform the code, the React code, during the compilation process. ESLint's job is to help catch any kind of report violation of the rules of React in your code, means in your component or in your hook. And this compiler code What it does, it performs all kind of analysis and the optimization. Okay, so this Babel plugin, ESList plugin, both uses the code from this compiler code to make sure that whatever they are transpiling or whatever they are validating, it goes along with the analysis and the optimization that compiler code does. Now, how does the flow goes? Let me just tell you. And this is kind of similar to the flow that we have seen over here. So let's say you have a React component or React hook. What Babel plugin does here, it will do the transformation. We know that. Another part of the transformation, this will create an abstract syntax tree. As it is a tree will have the nodes, right? I just now told that count equals to 10, const count equals to 10. In the abstract syntax tree, the node had somewhere we had const, somewhere we had count, somewhere we had equals, somewhere we had number 10. But when we are talking about a React application, there are a bunch of components. There are a bunch of hooks. So the AST for React, that what will be created, the node will have those components or the hooks. Okay, that is how the AST will be created. Now once the AST is done, now this AST that Babel created will be translated into something called an IR code. IR code is this one, right? Intermediate code generation. Before that, syntax analyzer, semantic analyzer, all this thing happen through ESLint plugin, because this is what it validates. Your component is correctly written, rules of React has been maintained, your hooks is correctly written, all these things are done. Then once this is done, this AST will be analyzed further, various validations technique with the ESLint plugin, that none of the rules are broken. Then it will try to, the compiler code will try to reduce the amounts of code and try to optimize it. It will eliminate all the date code, and it run multiple passes of optimizations cycle. These optimization cycles are done using memoization. The memoization technique that we done with React.memo, use callback, all are internally handled in the compiler code. We will see some example like how compiler behaves internally. Okay. Then after all these optimizations, validations, now we have an optimized AST, optimized abstract syntax tree, where each node, those components and hooks are optimized, date code eliminated, cached, memoized, everything. But this AST is something that cannot run on browser, correct? No, browser understand at the end of the day what? JavaScript, HTML, CSS. The React that we write, React component, that doesn't run on the browser, right? Even without React 19, without React compiler also, it has to get transpiled to JavaScript, because that's what our browser understand ultimately. So this AST, whatever this compiler got, it then convert back to an optimized JavaScript code. So for your optimized hook, there will be an optimized JavaScript code. For your optimized React component, there will be an optimized JavaScript code. That is what finally run on your browser. So this is how React compiler does its magic. This is how the things happen for React compiler. Hope this thing is clear to everyone so far. Okay. All right. Now we will move to seeing some code. So let's see some code and let's see an example. We'll take a project without the React compiler and try to see like how the project works, what are the kind of side effects we see, and then we'll configure React compiler into that and see like what kind of problem we solve, right? So let's see thing in action. So the project that what I am thinking that we will have a product list page. It means that a page where list of products are there, and this is a product page basically. This is a component, and this component receives two props. One is a heading, just to show a heading, and a list of products, which is like an array. On receiving those props, it channelizes those things into three child components. Okay, we'll see that in code, but first try to visualize. This heading goes to a component called heading, which is a presentational component, just shows the heading. That's what its job, nothing more. And along with that, as I'm having a products array, it also does a products.length and show the total products, as the how many products that we are showing, heading and how many products. Then there is a product list component, which take this products array as a prop. Just do a map iteration, ULLI, that's it. It shows the product list. And then out of these products, let's say there are 10 products, and each of the product is having a attribute called featured, true or false. Whatever the feature true, that means this feature products gets to this feature products component, and it shows the feature products. Very simple component, right? This is the component hierarchy. Now let's go to VS Code and try to see this component and see how things are working so far with this component. So let me just pull VS Code. Yes. So this is the one. Let me just make it little bit bigger over here. Forget about this header, React compilation lesson. This is the heading that I was talking about, the food product. There is something called food product one. I was doing some testing with it. And then it shows the number of products, which are like 1, 2, 3, 4. Okay. And it shows some number. I'm going to explain that what it is. And out of the 4 products, there are 2 products that are featured, like hamburger and hot dog are the featured. Okay. Now let's look into the code of this one. So this particular project is running with React 19. Okay. And I haven't installed anything else apart from that. This is the app.jsx file. Let's quickly look into app.jsx file. It has an array of food products, which is like 1, 2, 3, 4, 1, 2, 3, 4, these food products. This particular food product and this heading, the food products one, let's make it food products for a moment. The heading food product goes to another component called product page. Okay. Now this product page component, which is like this entire thing, we just now have seen in the picture, this product page component is broken down into 3 other components. One is heading, which is this guy. One is the product list, which is here to here. One is feature products, which is here to here. I'm not getting into the code of each of this because you can imagine like what it will be. If I go to heading will be a like simple H1. And this number is just the timestamp of the current time. Date.now, pure JavaScript, the current time timestamp. There is a purpose why I have added. And then for the product list also, it is simply doing an ULLI of the products that it has received as a props. I have a H2 called product list, which is like this particular thing. And along with that, again, date.now. You can imagine the same thing with the featured products as well, where I'm passing the featured products. And again, it is iterating through. And I have a featured list as a heading and then date.now. So right now it is showing, I mean, whenever this particular UI got rendered, that point in time, whatever the time it was, that particular timestamp is what it is showing. But why I am doing this? The reason that I'm doing this is if I come over here and this heading, this food product, if I'm going to add a S over here, making it plural, product to products. This is definitely going to render immediately because I'm changing it, product to products. But along with that, notice another thing is like the moment it become product to products, all these values are going to change. All these values are going to change, right? Just notice that first. So I'll do S, product to product. See, everything was 40 end with, now everything become 86. It's changed. Now you will say that, yeah, it will change because the component re-rendered. Re-rendering is not refreshing. Re-rendered means it's re-rendered the actual change in the virtual DOM. So that is great. But the problem here is the product page changed the heading. And the heading value, which is like the food products, I am using only in the heading component. Correct? The food products. This particular heading value is never used in product list, never used in featured list. Then why, just for changing this one, I am re-rendering the child components as well? This is a question people started asking before React 16.4 or React 16 that time. Why child component should be re-rendered? Because something changing in the parent component. Child component, nothing changed, no props change, nothing changed. But I am unnecessarily re-rendering my child component. Then React, being very smart, came up with the memoizations technique. So it told like, hey, what you know what? You can actually now do one thing. You can memorize this product list. you probably can memorize this featured list computation, and that's probably going to save you some cost. You don't have to really re-render your child component until unless the props for those things are getting changed. Okay, that is good. So how do you do it? If I go back to my slide once more, you will do it like this. So for product list, you will do a react.memo, maybe product list component, you get a memoized product component. For featured list, you can use memo, the computation is inside that, and then it's returning the memoized value. That's fine. But in both the cases, this memoization will work only if the products has not changed. But in our case, it is not the products. We have done with heading, right? So we also have to track heading, which is not at all related to either this, either this, either this, either this, because heading is only related to things over here. So memoization is good, but somewhere things are really not falling right way, the way that it is intended to. So that's the reason it came into the fact that we have to do something on it. Means being a React developer, React core team developer, they felt like we have to do something. So we have to optimize it in our way. We have to do this thing in our way so that developer really don't have to think about it. This kind of use cases, which is like bit tricky, where the props is not the child components props, parent components props, but still I have to stop rendering the child component. Let's introduce something called React compiler. So React compiler being a build time tool, now what we're going to do with this same application without changing much of the code, only through the configuration, we are going to introduce React compiler to it. And then we'll do the same thing and see like how it is going to improve this child component re-rendering for parent component props changes, right? So let's do that. Okay. So if you're using React 19 application and that is where you want to configure React compiler, it's all good. But people have started trying out this since it was announced, and with React 18 also, and also like for compiler to work, it is still experimental, right? It will take some time to get into production and things like that. So it might not really work for all kind of libraries that were designed in a very different way, not keeping React compiler in mind. So if you have a project, like a project you upgrade to React 19 just now, and now what you want to get React compiler into it. So what you can do first is to check whether your project is really compatible to get the compiler inside. So to do that check, I'll just now open the terminal. I don't have to look into the code. And I hope that this terminal is visible to you as well. I'm just increasing the size a bit. Yeah. Now what I'll do, I'll put a command. This command says npx react compiler health check experimental. So what it is going to do, it is going to check whether this project is compatible with React compiler or not. I have 5 components total. All the 5 components is checked and saying that, okay, you are running on strict mode. There is no incompatible libraries. It is compatible. I'm also managing and maintaining all the rules of React. So good to go. That is what it's showing. So if you're first time, if you're doing, make sure that you do this thing. After doing that, I told that there are 3 things in React compiler. One is the Babel, one is ESLint, another is the compiler code itself. So each of these 3 things you have to now install and you need to configure. So let's do that. So first thing is the ESLint. So for that, you can install it using npm install or yarnad or pnpm install, whatever your favorite tool is. And with that, you will be installing ESLint -plugin -react compiler at experimental. This is all there in the React 19 documentation or React.dev. If you go, the steps are very much clear, is all there. Now you install this. Of course, it's going to take some time, and after that, it will be installing this. And the installation is done. Now next, you will be go to the ESLint's configuration file, which you know is this one, ESLint.rc. And here you have to configure the React compiler. So 2 places you have to do. One is in the plugin section. Right now I have only one plugin, React-refresh. So here I'm going to add this plugin after this. Okay, so here I'll be adding this plugin. And then there are rules. For rules also, you have to add the rules. These are all in the documentation. In fact, I am also copying from the documentation only. Okay, so you added this ESLint plugin and its rule into ESLint configurations. That's it. ESLint is done. After that, you'll go back to your command prompt. You are done with ESLint. The next is about the Babel. So again, Babel React compiler experimental, yarn add, and I'll paste it. Here I'm doing Babel plugin React compiler experimental. Let's install Babel. Babel is done. And the last part is now to bring Babel into the context of this particular project so that React compiler kicks in. Now, this project is created using Vite, V-I-T-E. There are many other ways you can create React project, isn't it? Before Create React app was there. Now Vite is the one that is very much, front running. You can have an Next.js project, which is internally nothing but a React project. You can have a Remix project. You can have varieties of project. Now, for each of this kind of project, they come up with their own configuration and own configuration file. For Vite project, very easily you can find a configuration file called vite.config.js. Okay, this is a very basic configuration, nothing really much over there. It's a default configuration with every Vite project for React. You get this. Now here you have to configure the React compiler. So for that, first, what I'm going to do, I'm going to create a React compiler config object. Right now the object is empty. We are going to see few things that we'll be adding later point of time when I go to the tips and tricks section. But right now it's empty because we want to go with the default configurations altogether. And then in the plugin over here you have to do certain things. Here you can define different kind of plugin support for your Vite project. One plugin support that you can do it for Babel. It is also there in the documentation, React 9 documentation. You can just go and grab it very easily. So the Babel configuration is what I am putting here. I'll explain this. I guess I have missed one bracket somewhere. Just let me see this. Yeah. Mm. Copy pasting. Okay. Yeah. So what it is done, we had this React thing already by default. Inside that, I'm configuring the Babel plugin. And this Babel plugin React compiler just now we have installed, correct? Along with that, we are passing a React compiler config. For us, configuration is nothing. There is nothing in the configuration, but in future, we can add multiple, configuration that we'll see. Now with this, let us try this application once. I have refreshed it. Every time I'm doing a hard refresh, it is reloading, right? This is not the refresh because of your component state change or your data change. This is a hard refresh. Every time I'm doing a hard refresh, this is changing 1111. So I'll stop over here. Now I'll go back to my app.js file, JSX file. So we did it products last time, and now I'm going to revert back to product. Okay. This is everywhere 11. Last time when we changed this particular prop, setting props, everywhere the date changed because the component got re-rendered. But now let me see whether everywhere the date will change or it will remain same when I'm going to change this particular heading or anything in this heading. So I'm going to remove this S. Did you see what happened? The heading text got changed, but your date remains same. It didn't really change. Okay, let us go one level down. Let us go to this taco, and make it like Taco Bell. Taco Bell change. Taco changed to Taco Bell. Still, it didn't change. First, I can understand. I have changed the top level props. My child is not re-rendering. But now, I'm going to the child. I'm changing the child itself. I'm still feeling like this child, entire child is not re-rendering. It is just in place update. It is happening. And this is just happening because I have configured something into my bitconfig.js. If I just take away this code from here to here, this will be the older behavior. If I just take away this much, refresh this, and then come back to my app.jsx, from Taco Bell, if I go to again Taco, here is 20, right? See, it becomes 62. So now you understand how you just opt in and opt out with your React compiler just with this particular configurations, and that's how everything is connected. You have this Babel plugin, you have the compiler config, is bringing in all the circus of compiler into your code, and it is making it work. Isn't that amazing, right? Another thing that you want to point out over here, like when you are using React compiler, especially I think it is from React DevTools 5.0, they have added something amazing actually. I'll just go to F1 F12. I'll make it bigger. Just give me a second. If I go to components, you will see something like a memo and then this particular emoji. This will appear beside every component that your React compiler is optimizing. That is great. Now I'm saying everything you're optimizing. Of course, I have done something in the waitconfig.js file. So all the components, all the hooks that I have in this project been optimized. But I can opt out from one of the components saying that, oh no, this component doesn't need optimization, not even by the React compiler. Leave it out. For that component, is not going to show this memo stuff over there. So now in the component, when you are actually doing some amount of debugging, you know like which part is optimized by compiler versus which part is not optimized by compiler, right? So I hope this application makes sense to all of you. You understood, it's cool to you. And what I want you to do, I'm going to give you all this GitHub access, all this code. Whenever you have time, pull this experiment out. And I'm going to teach you something really amazing after that, like how compiler is doing this. That if you understand, and then you will be able to experiment a lot of things on yourself, be a compiler and do stuff. So let me go back to my slide for a moment and see like what I have after this. Okay, I have deep dive. Okay, so let's do some deep dive. So with React compiler, we also got something called a React compiler playground. I'll share the link again. And what you can do, if you want to understand how compiler is taking care of certain things, how it is putting this kind of updates into practice, how it is doing this kind of optimization, it generates the equivalent JavaScript code. Remember what compiler does? Or React compiler? Babel do the AST, then ESLint, then AST is again transferred to JavaScript code. So generate that JavaScript code. You can look into the JavaScript code and you can actually do a lot of stuff. So let's go to that particular piece. For that, let me just come out of this and let's go to React compiler. So this is React compiler playground. Left side, what I have, basically my heading component. I've just taken the heading component and pasted over here. You can paste any component of your choice. That is what I was saying, that after this, you can try your component and try to see what is generated at the right side and try to see like how you understand that code, right? So let me just explain to you. Okay. This particular component is name heading, having two props, heading, total products, you have seen just now. It has a JSX. The JSX having a navbar. Inside navbar, you have a heading. Inside heading, I am showing this particular heading, and then I'm showing total products. That's it. Very, very, good thing. And then it created this end result, which is a JavaScript. Now, if I look into this code, it looks like something gibberish, something that I don't understand very well. But if you look into little bit closely, it is pretty easy actually. What it is doing, it has taken something called T0. Okay, we had a poll like how do you name your variable, right? These variables are not usually seen by the outside people, so it's okay to name T0, T1. These are all like internal code. So this is T0 is something which is like an you can say your prop object. This is what it T0. Now T0 can be destructured because it's an object. Object can be destructured. After destructuring, you get a heading, you get a total products. So this line is something very well understood, I'm sure. Then it creates an array of three element. Underscore C is a hook that compiler uses to create cacheable array. Cacheable array means in that array, each of the element will be cacheable. Okay, can be cached. So it gives me a cacheable array. Dollar is a cacheable array of three elements. But why three elements? How we decided that it is three? It is because it has two props where the optimization is required, because these two props can change. These are the input. And if these two props change, any of these props change, the output resultant JSX also will change. So it has to cache this, also cache the output JSX. That's the reason it has created an array with 3 elements, where each element can have one of the cacheable item. And for us, the cacheable items are heading, products, and the JSX. It goes with the order. First it says heading. So the $0, dollar subscript 0 will have heading, dollar subscript 1 will have total products, array starts with 0, you all know, and dollar subscript 2 will have this JSX. After that, it will use something called a memoization block, means a caching block. A very basic level, ground level, caching is a if else, correct? If I finding in the cache, use that. If I don't find the cache, else go to the data store and fetch the fresh one. That's it. At a very basic level, this code is nothing but a simple memoization block with if else. What it check over here, $0, it had cached the initial heading value. $1, it had cached the initial total products value. So if none of them are change, right, then you get it. Your JSX, you get it from the cache itself and return if none of them has changed. You see here, $2, I told this entire JSX, the first time whatever it computed will be stored in $2. So just return that JSX because heading and the total products, none of the profs have changed. But if any of this got changed, then you recompute your JSX and then update your $0, $1, $2 with the new value of heading, total products, and the JSX. The resultant JSX is inside the T1 variable, resultant JSX. A simple JavaScript logic for caching certain things into the index of array, either return from the cache value or compute the value and putting into the cache. So this code ultimately, this component code ultimately will be this JavaScript code, and that's how it will result out, right? So now you can understand, like if the heading changes, it is going to impact only this guy. It's not never ever, because it is in the AST now. It is never ever, it is in one node, it is never ever going to impact something beyond this particular component. I would like to request all of you. I mean, this session can go for 2-3 hours if you would like to, by getting into different kind of components and explaining like each component how it is doing the output. But rather, I would request each of you, if you are interested, go to React compiler playground, put the component that you would have memoized yourself with use memo, React memo, or use memo, see what it is output, what output it is, and see like how exactly it is managing. This is something really amazing that I find. All right, so this is where we are. I'm coming back to my presentation again, and we did a deep dive, of course. Okay, some tips and tricks I'm going to share, and these are actually important stuff. Okay, so let me go back to the code once more. I'm almost towards the end of it, if anybody is getting bored. All right, so we told that we have done some configurations over here. The configuration is about, we told like this is the plugin to use because this is going to do the transformation and all these things, and ESLint is already there. We have a React compiler config through which we can pass some kind of configuration. Now, this way of opting in for React compiler would make every component memoized by default. But you might want that certain components you don't want it to be don't want it to be optimized. So in that case, you can use a mode, a compilation mode. So in that case, you won't have this as empty. Now you understand like what is the use of this configuration. You can pass different kind of configuration. One configuration is the compilation mode, is called annotation mode. When you are in the annotation mode, now you can go to a particular component. For example, now I can go to say product page.jsx, and on top of that, I can use a particular directive. Who are in the Next.js, you already use the directive, use client, use server, and all these things, right? In fact, React 19, you can create server component, client component. You can create client component with use client and all. Here, for example, I want to memorize or optimize only this component, then I will put use memo only to this one. So only this component will be now optimized. None of the other component will be optimized because I am running on the annotation mode, and whatever I will annotate, only those component will be optimized. So if you want to run yourself in this mode, that also fine, because I understand like there are a lot of projects, maybe wherever you're working or maybe your own application, they could be mammoth, and you are really unsure like after putting React compiler how the things are going to behave. Something you don't want to cache, you know, but it is doing it. You might want to come out of that behavior. So you probably selectively want to get to React compiler, right? One by one. So in that case, this is use memo is fine. Now, after using use memo like this, the directory, this is not the use memo hook, by the way. You might feel like, okay, I wanted to optimize this particular component only, but look like it is misbehaving. I probably need to do certain amount of changes into this component before I can use this. So instead of removing this directive completely, you can use it like use no memo. So what use no memo is going to do is basically, even if you are annotated with the annotation mode, that means if you have 5 component, you want to optimize 3 component. Within 3 component, you can choose one component which you want to defer for the time being before you fix something back and then again bring the optimization back. So these are some simple tips and tricks that you can utilize with React compiler configuration. That is great thing. And then the last thing that I want to talk about is, uh, some people ask me always, like, can I use React compiler with React 18? Yes, you can definitely use. There are hacks. Actually, React 19 compiler have created a working body. Any of us can join that working body. You just need to declare how much time you can give for the working body. So the working body come up with a lot of these tips, tricks, proposals, and all. They are there on the GitHub. Again, I'll share the link probably when this video goes to React Chennai's YouTube or any place. There in the description, you should be able to see these links. So they came up with the recommendation, like, if you want to use the React compiler with React 18, what you don't have in React 18, that underscore C hook I told, right, which creates the cacheable array. In React 18, you don't have. That has got introduced in React 19. And that's the heart of all this optimization technique, creating that cacheable array. So if you don't have that, how is your compiler going to work? So either you have to create something which is like that underscore C, or you have to use a polyfill which will give you that underscore C. So you have to do certain circus around it if you want to use it with the earlier version than React 19, the React compiler. But recommendation is always that you go with React 19 always, right? So with that, I think my talk is over, and I would like to request you, if you want to connect with me, you can just scan this QR code. It has all my details that you can connect to, or if you want to talk to me, you can get there. And if you like my teaching, you can always subscribe to my YouTube channel. Hope you learn more. So with that, I would like to thank everyone who is listening to me, almost like 80 people, and thank you the organizers for having me today. Thanks.
Okay, so am I audible?
Yes.
Yeah, so I just wanted to end this with a quote. So I just read this quote somewhere. 80% of the result actually comes from 20% of the activities. So just like what Tapas said, on a Saturday evening, if you guys are here, we wanted to make sure that we give the best possible guy out there to teach about React compilers. So we started with almost 70 odd people, and we are ending with almost again 70 odd people, and that is Tapas for you guys. And and also to Tapas, let me tell this frankly, when I gave the intro, I was shit scared, but you sounded so calm, so peaceful. I got that energy now, and I'm so energetic now. And also the way that you went with explaining about React compilers, starting with the optimization techniques, teaching about compilers, then about React compilers, and then your working demo, and finally the deep dive. That was fantastic.
Thank you.
So, guys, like if you have any questions, you can raise your hands so that like we'll unmute you. You can ask your questions directly to Tapas. Or else you can also post it in the comment section, which Tapas or the volunteers will reply to.
Yeah, I'll
So
just keep my screen shared, so in case somebody want to scan, also can scan it. Yeah, I'm open to questions. Just browsing through the. Thank you, whoever think that it's a good session. Thank you very much. And I saw a few comments like folks are thinking that's a good session. Thank you very much for that.
Suppose there is one question by Anand. He said, I have a migration project. I'm going to migrate to 19. I have already few optimizations
With use
techniques.
memo and all, right?
Yeah.
Yeah.
Do we need to
Yeah.
remove those to migrate to 19?
Yes, yes. So, yes, Anand, that's the right way of thinking about it. You might not want to, that's what I was saying, that annotation mode, that probably the most preferable mode for this kind of project. go for the annotations, for those components which doesn't have anything to do with any kind of already given memoizations. So you can see that impact already, right? For rest of the component, it is not just the memoizations thing that the compiler is performing. It is beyond that. It also remove the date code and all these things, right? So you can get those benefit out of it. Then go for the components where you have done your own memoizations. You remove those, because what a beautiful thing about it is, like, if you have a use memo or the use callback or react.memo, this is just a syntactical thing that you have put as a wrapper on top of your own logic. So removal of it is not really difficult thing, right? Maybe someone will come with some kind of migration tool or some kind of VS Code extension which will mark all those existing memoizations thing and boop, remove tomorrow. I don't know, some developer will create, I'm sure, once React 19 comes in. So until that happens, you go one by one, but ultimately, yes, it is something that you need to remove. Let's give the job to the master. Let's not do it by ourselves.
So, thank you, Tapas. So, guys, like, if you have any doubts, you can ask. So, do we have anything?
Yeah, there is one from Gautam. He said, "Can I make use of React 19 when my component library uses React 18?"
You can, you can use React 18 based component library, React 16 based component library, no issues at all. What will happen is, like, when you're using the compiler, so compiler goes through that, ESLint will go through some rules of React. If your library is designed in such a way that it broke some rules of React or taken some kind of shortcut to do these things, maybe it has its own ESLint, but sometimes developers are lazy, right? We disable even ESLint on the line, right? We do that thing, even the ESLint there in the project. Maybe the library has managed in that way. So if it is breaking any kind of such rules of React, then that health check, that whatever I showed before, once you run that health check, is going to report that it is not going to stop you from using the React compiler, neither React 19. It is just going to tell you that you are now getting into might be a danger because you are using a library which is not adhering to React rules. So please be cautious about it. But there is no really stoppage that you cannot. You can. React compiler is support for React project. Yeah, I just answered that towards the end. You can, but you have to do it a bit hacky way. Okay. Any other questions?
So, do we have anything? No, right? No, I guess.
There's one question about benchmarking. How about the performance benchmark? How to compare before and after migration to 19 and
Yeah.
after?
So right. So the React Day that the React team has done is there in the YouTube already. So they have actually put out this benchmarking exactly with the data running with both React 18, 17, 19, the three benchmarking. So that's why were saying, like, there's a performance without any kind of memoizations, handmade memoizations by the developer, performance with the memoizations that is get into, plus performance with React 19 compiler without any kind of handmade memoizations. So the benchmarking, the result was, really good, but it was React conference, so it has to be good. It has to look good in the presentation. I have not done this benchmark myself, so I cannot really comment on anything concrete, but from the data what I have seen, it looked really great. Satya is already there. uh, I
Yeah.
think, yeah, so he can comment that benchmarking. And he also said that is officially supported, so this is great. This is great. I have not tried. So I have seen some benchmarking, like, only on that YouTube. Like, there is some benchmarking, but I'm not really tried myself, so cannot comment. Okay. Anything else?
So I guess we'll wind up.
Yeah, I think so.
So before we actually wind up, let's turn on our video camera for a second so that we'll take a screenshot and then we'll wind up. Let's pause, guys. Yeah, the screenshots are done.
All right.
So yeah, I guess we'll wind up. Thanks, Tapas. Thanks,
Thank
guys,
you.
for joining.
Thank
It
you
was
very much.
wonderful. So
See
let's
you in
wind
the
up.
next one. Bye bye.
See you again. Yeah, bye.
Bye bye.